Okay, so here's the lesson for section 2.4, the equation of a circle. First of all, let's define a circle. A circle is a set of all points that are the same distance from a fixed point, the center. Okay, so a circle is the set of all points, all the points here that are the exact same length from the center. Okay, so they all the points of the circle lie on the radius of the circle. Okay. The radius is the distance from the center of the circle to any point on the circle, okay? So the radius, there's a radius here, here, okay? The radius is the length from the center to any point on this circle, any point, okay? So if we want to find the length of the radius of the circle, okay? I can use the length formula that we came up with in the previous lesson, okay? So find the length of the radius of the circle using the line that starts at the origin, okay? We know the radius is from the center, okay? And it ends at 0.6, -8, okay? So I've told you 0.6, -8 is on the circle. So if we want to find the length of the radius, we go from the center to that point on the circle and use the length formula, okay? I should also point out origin. Okay, that word right there, that means at point 0, 0. Okay, all the circles we're going to be working with in this lesson are centered at the origin, meaning the center is at the coordinate 0, 0. Okay, so I should also clarify what we're going to do right now is we're going to try and come up with a formula for the equation of a circle. Okay, and how we're going to do that is by discovering how we would calculate the length of the radius. Okay, because we know every point on a circle is on the radius. Okay, every point on a circle is on the radius. Okay, we know the radius goes from the center to every point on the circle. Okay, so let's first off just look at finding the length from the middle to 0.6, -8, which is on the circle. Okay, so I can use the length formula. We learned this last lesson. The length of a line is equal to the square root of the run squared plus the rise squared. Our points are the origin, 0, 0. That's my first point, x1, y1. And point A is on the circle, that's at 6, -8. So that's my x2, y2. Plug that into my length formula. So my length from O to A, x2 minus x1, so 6 minus 0. 6 minus 0 squared plus y2 minus y1, -8 minus 0, -8 minus 0 squared. So my length is equal to, so 6 minus 0 is just 6. Okay. And -8 minus 0 is just -8. Square those. 6 squared is 36. -8 squared. A negative number squared becomes a positive number. Okay, anything squared is positive, so -8 squared is 64. -8 times -8 is positive 64. 36 plus 60, oh, sorry, I wrote the squared again by accident. Okay, so 36 plus 64, that conveniently gives us 100, which we can square root nice and evenly. Square root of 100 is 10. Okay, so the length of the radius is 10. So the length from the center to every point on this circle, every point should be 10. Okay? Every point on the circle is the exact same distance from the center. Okay? By definition. Okay? So notice when we're calculating the length of the radius, because all the circles we're working with are centered at 0, 0, notice the point on the circle is 6. The point on the circle is 6, -8. And look what after we simplified, we put in our x2 minus x1 or y2 minus y1, we're subtracting 0 both times from our run and our rise. Okay? We're subtracting 0. So essentially there's not really much point in writing that. Okay? If you look at the relationship between the simplified version, okay, and the point on the circle, notice the 6 is here and the -8 is there. There's not much point in writing the -0. So what we can come up with here, if we want to find the general equation of the circle, okay, the radius, so if I just have, I'm always going to be centered at the center, okay, so I'm always going to be at 0, 0, and to any point here, any point x2, y2, keeping in mind that this here is my x1, y1, my origin, where the circle is centered. Any point on the circle, they're all going to be the same distance away. They're all going to be the length of the radius. Okay. So any point x2, y2, let's come up with an equation that will satisfy for any point on the circle. And that'll give us the equation of a circle. So we know the radius of a circle, length of the radius, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We know that we're going to be subtracting 0 both times, okay? Because our x1, y1 are 0. Those are zeros, okay? When you subtract 0, you're essentially doing nothing, okay? So what we're left with here, so there's no point in subtracting the 0. What we're left with is the square root of x2 squared plus y2 squared. And x2, y2 is any point on this circle, okay? Now, let's, to clean this up a little bit, we don't want that big square root sign there. We know the opposite of square rooting is squaring. So we can move that square root sign to the other side by squaring the other side. Okay, so we get r squared equals x2 squared plus y2 squared. Okay, and because we know it's always centered, at the origin, we know it's always at 0, 0. We only have one point in our equation. We only have one x and one y in our equation, so we don't have to allocate a number signifying which point it is, because we're only interested in one point really on the circle. Okay, we know it's centered at the origin, and we want an equation that'll take into account every point on the circle. So we don't have to write the subscript 2 here. Okay, we know the radius squared is equal to x squared plus y squared. Okay, that's true for every point on this circle. Okay, if we plug in the x and the y coordinate of any point, add the squares, okay, of those points, and that will give us the radius squared. Okay, so there's the equation of our circle. Hopefully you followed what I was doing as I was deriving that formula there. But now I'll show you how we're going to use that. So the important part now is now that we have this equation, we've come up with the equation of the circle. The radius squared is equal to x squared plus y squared. Now we want to be able to use it. Okay? So just to clarify this rule, we came up with one more time, sorry. If the center of the circle is at the origin, that's important, okay? Keep in mind, we're working with circles that are centered at the origin right now. If they weren't centered at the origin, we would have to take into account the x1 and the y1, okay? They wouldn't always be 0, so our equation would have to be this full thing. We wouldn't be able to simplify it. We wouldn't be able to simplify it into this. Okay, but because when a circle is at the origin, okay, and the radius is r units, then r squared is equal to x squared plus y squared. And all we're going to be working with right now is circles that are centered at the origin. Okay, so what you want to take away from this: radius squared equals x squared plus y squared. R stands for the radius. X and y stand for all points. It stands for the coordinates of all the points on this circle. So every coordinate on the circle will satisfy this equation. Okay? Let's go ahead and work with that. Let's write the equation of a circle with the center at 0, 0. Okay? Just like I said, we're working with circles that are centered at the origin and a radius of 3 units. So we're given r equals 3. Okay? I know the equation of a circle is x squared plus y squared equals r squared. Okay. I could write r squared equals x squared plus y squared, or x squared plus y squared equals r squared. They're equivalent. Write it however you want. Okay. I'll probably generally write it in this form. Okay. So what I'm going to now do, I know r is 3, so I'm going to plug that in for r into my equation. I get x squared plus y squared equals 3 squared. Okay, now what we have to do, just square that r. Okay, I know what 3 squared is. I can simplify that. X squared plus y squared equals 9. And you know what? We're done. That's the equation of that circle. Remember when we wrote the equation of lines? We'd have like y equals 3x minus 5. Okay. We subbed in for everything except for, we subbed in for our slope and our y-intercept, but we don't plug in for x and y, because this is a general formula for every point on that line. Okay? So what we have to do when we write the equation of a circle, we want it to be the general equation for all points on the circle. So we don't plug in for x and y. Okay? We only plug in for our radius squared. Okay? And our radius squared was 3 squared, which is 9. Okay? Good. Okay. Now, let's go ahead and do another example. Write the equation of a circle with center 0, 0 and a radius of half units. Okay? A radius of half a unit. Okay? I should say half a unit. Okay. I know the equation of a circle is x squared plus y squared equals r squared. Or if you prefer, r squared equals x squared plus y squared. But I'm going to write it like this. Okay? I've told you that r is equal to half. I'm just going to plug in r equals a half into my equation for my circle. X squared plus y squared equals a half squared. Okay, I put in brackets. Just remember I have to apply the square to the numerator and the denominator, okay, of my fraction. 1 squared is 1. 2 squared is 4. X squared plus y squared equals a quarter. There is the equation of my circle. Okay? So in your final equation, don't plug in for x and y. You just want to be plugging in for your radius squared. Okay? Always remember to simplify that radius squared. Okay? 1 over 2 squared means 1 over 2 times 1 over 2. Multiply the numerators. 1 times 1 is 1. Multiply the denominators. 2 times 2 is 4. Okay? That's how you came up with that. Okay? That's the algebraic reason behind squaring a half. It gives you 1 over 4. Alright, let's do another example. What is the radius of a circle defined by the equation x squared plus y squared equals 9? Okay, so we're working backwards now. So we know the equation of a circle is x squared plus y squared equals r squared. But right here, okay, I've got the equation of this specific circle. Instead of an r squared, I see a 9. So I know my r squared value is 9. So how do I get just r? I have to get r by itself. The opposite of squaring is square rooting. So when I move that square to the other side, it becomes a square root. Square root of 9 is 3. Okay? So my radius is 3 units. Perfect. Good. So when you're given the equation of a circle and you're asking for the radius, and it asks you for the radius, take the r squared value, square root that, that gives you the radius. Okay? So let's try another one like that. What is the radius of a circle defined by the equation x plus y squared equals 64? Okay? So remember the equation of a circle, x squared plus y squared equals r squared. Okay? I see that my r squared value is 64. So to find the radius, I just have to square root that 64. Square root of 64 is 8. 8 times 8 is 64. Okay? So my radius, 8, I should write units here, is 8 units. Okay? So far, we've done 2 questions where we're given the radius, we want to write the equation. Okay? And we've done 2 questions where we are given the equation and we find the radius. Okay? Now let's do a different type of question. Okay? A circle has center 0, 0. That's important. Okay? We know every circle at center at 0, 0 has the equation x squared plus y squared equals r squared. Okay? And it tells us it passes through the point 8, negative 6. So I know the point. I know every point has an x and a y coordinate. So I know the point 8, negative 6 is on the circle. Okay? So we have one point given to us on the circle. Okay? A point has an x and y. We're given the point. It's 8, negative 6. And we know that has an x and a y coordinate. Use the circle formula and plug in the x and y given. So we're given a point on the circle. We plug in our x and our y value. Okay? And we can solve for r squared. Because remember, when we write the final equation of a circle, okay, the final equation of a circle, like this right here, has a value plugged in for r squared. Okay? That's what the final equation will always look like. It always looks like x squared plus y squared equals a number. So we have to figure out what that r squared value is. In order to figure that out, I can plug in for x and y, because I'm given a point on the circle. I can solve for r squared. Okay, so plug in, I get 8 squared, put in brackets, okay, so I remember to square the negative 6, and not just the 6, equals r squared. 8 squared is 64, negative 6 squared is positive 36, squaring a negative gives us a positive. So 64 plus 36 is 100, so my r squared value is 100, okay? I don't have to solve for the radius. Okay, the question doesn't ask me for the length of the radius. If it did, I would have to square root that 100 and find the length of the radius is 10. Okay? It doesn't ask me for that. It just asks me for the equation of the circle. And to write the equation of a circle, I need just the r squared value. And I have that right here. R squared is 100. So I can replace the r squared with 100, and I'm done. So the equation of my circle is x squared plus y squared equals r squared, and I know r squared is equal to 100. Done. There is the equation of my circle. Okay? Now, next, this is an extension off of that question. Okay? It might ask you, is the point -5, 9 inside this circle? Okay, it might ask you, is it inside this circle? It might ask you, is it outside? Actually, I'll write that in there. It should say, is this point inside, outside, or on this circle? X squared plus y squared equals 100. Okay? So we just found the equation of the circle. It's x squared plus y squared equals 100. Now it's asking us, is the point -5, 9 inside, outside, or on this circle? X squared plus y squared equals 100. Okay? We know the equation tells us every point on this circle, okay? The equation tells us the length of the radius, okay? I know the length of the radius is 10, okay? So what I can do here, I can plug in, I know this point here is an x and a y coordinate, I can plug that in for x and y, and I can compare my result to the radius squared. If the value I get for x squared plus y squared, okay, I know that'll give me an r squared value. If the value I get is equal to 100, is equal to the radius squared of this circle, then I know the point is on the circle as well. If the r squared value I get when I plug in for x squared plus y squared is greater than the r squared value of this circle, then it lies outside of the circle. If the r squared value I get when I plug in x and y, okay, is less than 100, the point lies inside the circle. Okay? So plug the x and y values from point B into the equation of the circle. Okay? I know the equation of the circle is x squared plus y squared equals r squared. Okay? Plug it in. So I get -5 squared plus 9 squared equals r squared. That gives me 25 plus 81 equals r squared, and that gives me 106 equals r squared. So the r squared value, okay, of this point here, from the origin, okay, is 106. 106 is greater than 100, which is the r squared value of the circle that is in question here. Okay, so because 106 is greater than 100, so when the r squared value of the calculator is greater than the r squared value of the circle that's asking us about, we know the point lies outside the circle. Okay? So, therefore, -5, 9, therefore B, point B, -5, 9, is outside the circle. Okay? Another important thing to note here, don't get caught up always trying to compare the number to 100. We're only comparing r squared to 100 because the radius squared value of the circle that we've been working with in this question was 100. Okay? If it asked us about does -5, 9 lie inside or outside the circle defined by the equation x squared plus y squared equals 125, we would compare the r squared value. When we plug in -5 and 9 into the circle equation, we compare the r squared value to 125. and 106 is less than 125, therefore the point negative 5, 9 would be inside the circle, because the r squared would be less than the 125. Okay? Let's do another example. A circle has a center 0, 0 and passes through the point 3, 4. Find the equation of a circle. So similar to question 5, find the equation of a circle when you're given a point on the circle. We know a point has an x and a y coordinate. We know the equation of a circle is x squared plus y squared equals the radius squared. Okay? So all I have to do, plug in for x and y. 3 squared plus y squared. Oh, and I know y squared is 4. Plus 4 squared equals r squared. I get 9 plus 16 equals r squared. 25 is my r squared value. Okay? I know when I write the final equation of a circle, I don't plug in for x and y. I only plug in for my r squared. I know r squared is 25. Okay? So the final equation of that circle is x squared plus y squared equals 25. Okay? Perfect. Last example. A stone is dropped into a pond, okay, and sends out a circular ripple whose radius increases by 5 centimeters a second. Find the equation of the circle 12 seconds, okay, after the stone is dropped. So I want to find the equation of the circle 12 seconds after the stone is dropped. I know it increases by 5 centimeters a second, so after 12 seconds, my radius is equal to, it increases at 5 centimeters a second, so after 12 seconds, so 5 times 12 will tell me my radius. My radius, 5 times 12, is 60. Okay, my radius is 60 centimeters. Okay? So we're given the rate that the radius is changing. We need to determine how long the radius will be in the time given. So the time given is 12 seconds. So after 12 seconds, we know increases at 5 centimeters a second. It'll be 60 centimeters will be the radius. When I'm given the radius, I can write the equation very easily. I know the equation of a circle is x squared plus y squared equals r squared. Remember, the circles we're working with are all centered at the origin. That's why we're able to use this formula. I know my r value. R is 60. So plug in 60 for r. Put in brackets. Don't forget to square it. I know what 60 squared is. Don't forget to simplify that in your final answer. X squared plus y squared equals 3600. Okay, there's the equation of the circle, and we're done. Okay, so that's all there is to circles. Let's do one more quick example. Circle has a center 0, 0, passes through the point negative 3, negative 6. Find the equation of the circle. I know the equation of a circle is x squared plus y squared equals r squared. In order to write the equation of the circle, I need the r squared value. I can calculate that by plugging in a point. I'm given the point on the circle. I know every point is the same distance away from the circle. That's why I'm able to use this adapted length of the radius formula. That is our equation of a circle. Okay, so I plug in my x and y in for x, my negative 3, negative 6 in for x and y. Okay, I know that point is on the circle, and this equation satisfies every point on the circle. So I do negative 3 squared plus negative 6 squared. Gives me my radius squared. That gives me 9 plus 36 equals r squared. Okay, 9 plus 36 is 45. So my r squared value is 45. When I write the final equation of a circle, I plug in for r squared. Not x and y, just r squared. Okay, my r squared value is 45. Okay, I don't plug in for x and y because this is the general equation for all points on the circle. For all points on the circle, all points have an x and y coordinate. Okay, let's see if there's anything else. Okay, so that's it. So the 3 types of questions pretty much that we did, we were given the radius and we had to find the equation of the circle. Okay, so we were given the radius. If I was given the radius, I plug in for r and then square that to find the equation of the circle. Or I'm given the equation of a circle, so I give you the equation of a circle and I ask you for the radius. So I give you the r squared value. You have to find the radius by then square rooting that. Okay. Or the other type of question I gave you is if I give you a point on the circle. Okay, so I give you a point on the circle, and you plug that point in for x and y, which allows you to solve for r squared. Then you write your final equation by subbing in for only r squared. Okay? So those are the 3 types of questions. There's also application types of questions for this section. So make sure you do the homework and attempt those, and ask me if you have any questions with those. Okay? So don't forget to go to jensenmath.ca to get the worksheet. And that's it.